Hey all, this is Sunil. I will be presenting my project AWS Bedrock based LLM conversational API with Ollama integration and Docker included. So let's look at the description. So this project demonstrates integrating AWS Bedrock, Ollama, Lambda to create a conversational API, similar to chatbot kind of an application where the client being Ollama and the server being Bedrock. So we also used Docker for containerizing the Scala application, which will be deployed locally, and we'll be using API gateways for managing the API, which is used to access the AWS Lambda. Let's look at the workflow. Before that, the architecture includes the client interface where we can use a Postman or a curl to make the requests. We'll be making get and post request. We'll see that later. We are using Akka HTTP server for listening to incoming requests and also routing them. We'll be using AWS Lambda, which will be the main point to communicating with the AWS Bedrock, and it is also making gRPC calls. Next is AWS Bedrock. It is used for generating the text messages and responses very similar to a chatbot. We are using Ollama. We'll be installing that locally, and this the input to the Ollama is the output of AWS Bedrock, and the input to the AWS Bedrock will be the output of Ollama. Next, we'll be using AWS Gateway to interact with the API which communicates to AWS Lambda. So this is our high level diagram. We'll be giving our seed input, something like hey, what are your superpowers, something like that. So this input is going into the AWS cloud provider platform and reaching our EC2 instance. The EC2 instance contains a Akka HTTP server along with Ollama installed in it. So the EC2 instance or the Akka server makes a gRPC call to AWS Lambda, which then routes the request to Bedrock. The reply from the Bedrock is routed along the same way back to Ollama, which is installed in Amazon EC2. So the conversation goes on between Ollama and the Bedrock using Lambda and our Akka server. So at last the output is saved in a YAML file. Let's look at the demo. We have two demos, one is locally and one is Docker. So this is our GitHub repo. So I have written all the required information. We have the description, architecture overview, project structure, prerequisites, steps to execute the project locally. So how to configure the gateway API, how to deploy the API, how to deploy AWS Lambda, Bedrock, how to configure the IAM policies. We are giving only the required IAM policies that are required for this project to be ran. How to install Ollama locally. We can also test our application using SPD test. There are integration unit and end-to-end tests. So there is also an example of API request of Postman and the sample output. So it's a chat between Ollama and Bedrock, how they are interacting with each other. For example, we start with hey, if you had any superpowers, what would it be and why? So the Bedrock replies that so it wants to have some capabilities and perspectives of human nature. So we again the Ollama reply replies that what capabilities do you think and what are the limitations. And Bedrock replies that me to understand the capabilities of each AI model, something like that. They keep chatting each other. Next, I have also steps to execute in Docker. Yeah, that's about the GitHub page. So let's look at our code, and we'll also go through a demo after we go through our code. Starting with the source folder. So I have an AWS subfolder, lambda.py. So this particular class is designed to handle incoming requests and interact with the AWS Bedrock LLM to generate text-based output on user input. So upon receiving an event, it decodes to base64 string, and the input contains the body as well as the maximum words for the response. So the function extracts these details, then invokes the AWS Bedrock model using the Boto3 SDK, and the Bedrock model processes the input and generates a response, which is then truncated to specific word limit. So the Lambda returns a JSON response which contains the original input and also the generated input. If there are any errors, we are returning a 500 with the error message included in it. So this is about Lambda. We do have a protobuf class. We have query request and query response, which the 1 and 2 are the ordinals, and the input request contains the input and the maximum words to be truncated, and the response includes the input request itself and the output as well. So we have a application config file. So there are few configurations related to Ollama, like the local host. We are using a different URL, and for the Docker host we have a different URL. The model we are using is Llama 3.2. Even for the Docker we are using the same Llama 3.2 model. The query timeout is set to be 5 minutes, is equivalent to 300 seconds. We are using 2 iterations for simplicity and reducing the cost of AWS usage. AWS FreeTAD does not contain AWS Bedrock along with it. So we are setting the maximum words as 100. This would also be helpful for AWS Lambda. Lambda is costed based on the input that goes through it as well, and also the number of executions. So we have this AWS Lambda API Gateway. We'll see how we got this during the demo. We have something called environment variable. It can be set to local or Docker. Initially we'll set it to local and see how the execution goes on. Next is the output path. For local output path, we are generating the response here itself under the resource folder. For Docker, it would be in the container. We have named the container prefix as LLM. Next, going to the utilities subfolder, we have a config loader which is used to load the configuration which we saw earlier. This is a JSON formats. So we are providing custom JSON serialization and deserialization for protobuf generated classes, query request and query response, which we saw earlier. It also uses intermediate classes, LLM query request case and LLM query response case to simplify the conversation process. The JSON format objects define implicit root JSON format instance, which handles the conversation between JSON and the intermediate classes and also the protobuf class. Next is output writer. As the name suggests, it is a utility to generate the YAML file what we saw. So we have the YAML helper object, which is responsible for managing and saving the results in the YAML format. It uses snake YAML library for handling the YAML and providing the functionality to collect and store the output in a structured way. The output writer case class holds a question, uh, and the corresponding LLM response. I can show an example here. So here's the question and here's the response, and so we keep on concatenating the messages and we build the YAML. Next is Akka HTTP server. The simple class, we are connecting to localhost 0000 and port 8080. So it serves a HTTP request defined in endpoint or routes object. It uses the Akka streams and actor based concurrency model to handle requests asynchronously. The server is initialized with actor system and the actor metalizer and an execution context for handling asynchronous operations. So additionally, I have set the server to shut down after 30 minutes of inactivity. This will unbind the server and terminate the actor system. The server also informs user when it starts and when it ends, so we have logs for it. Next, let's see the endpoint class. So in the endpoint class, we do have three endpoints which are interacting with the LLM model. The first endpoint is a single response query. So this is a get request, and it also expects a JSON payload, which is representing the query request uh, data type or data structure. We will see sample responses later. The next endpoint is conversation query. It also requests accepts get request and accepts the query request data structure, same as before. Next, we have a health path just to check if things are working or not. It doesn't really make a third party request. So we have also added logging, which uses SL4J, and all the endpoints are concatenated with each other. Next is a Lambda invoker. So as the name suggests, this class is used to invoke the Lambda. Uh, so this is responsible for sending HTTP GET request to an API endpoint for querying the LLM, the Bedrock. Uh, so basically, the task it is performing is that it is creating a request, a GET request. It includes a headers, URL, payload, which is a protobuf object, and it sends a request using the Akka HTTP server. It makes HTTP single request. So well, about handling the request, if it is 200, we are returning the response body with 200 response, or else we are throwing a runtime exception indicating that we have seen a failure. Next is Ollama API client. So this object or class is responsible for maintaining the conversational loop with a AWS Bedrock, and it makes multiple API calls and multiple iterations. So we have the start method. This initializes the conversational process. It initializes the Ollama API client and defines a number of iterations for the conversation. We can set the iterations in application config. Right now we have set it to 2. Next is um, process iteration. This method handles each iteration conversation. It sends query requests to the Lambda using Lambda invoker, and it also uses the Ollama API to generate the follow-up questions based on the LLM input. The response is also logged, and it is also added to the YAML file that we are generating. Next we have initialize Llama API. It uses application config and loads the required configurations and initialize the Ollama API. We have a test for Akka HTTP server and the config loader. We do have an end-to-end test which runs the whole flow from top to bottom. We have integration tests covering multiple classes, for example Akka HTTP server with endpoint and Lambda invoker with Ollama API client. Next, for Ollama API client we have a unit test. Next, we do have a Docker file where we are using the base image as OpenJDK 17. We're setting working directory as /LLM. This is also the file path where we are actually saving the output file. And next is we are copying our jar to a easier name called LLM jar. Next we are exposing the 8080 port which is required for the Akka server and 11434 port which is required for Ollama. Next we have a command line where we are starting the Ollama server, and also we are running the Java jar what we have. Next is AWS. For AWS, first things first, we have to have IAM roles to set up the services. So I do have a detailed steps in my GitHub README. So basically, we have to make sure that all the services should be accessible with all the services, inbound and outbound rules both, and also read and write access based on the service. Next is API gateway. We need an API gateway. This is just a wrapper to the AWS Lambda. To access AWS Lambda, we need to add an API gateway. I have created an API gateway called LLM Lambda API, and we need to add a stage for it. So I added a stage called test, and so this particular endpoint will be the AWS gateway link what we have pasted in our application config file. Next is AWS Lambda. So for the AWS Lambda code, it can be copied from the AWS subfolder. So we do have the code here. It handles the gRPC requests which are base encoded, and it also sends back the same. We can test the AWS Lambda using this feature. So I have a body here which is a base encoded string which says the same question what we have been using in the Postman. So I'll try to test it out. Let's see what happens. It takes a few seconds for the execution to complete. So we see that the input was a slow blink from a cat, like a, and the output was node from a human. It's a sign of continuity and trust and few more things. So this is the input and output. So this is about Lambda. So Lambda is interacting with AWS Bedrock to produce this output. About AWS Bedrock, we are using the meta model Llama 3.1, 8 billion words. So you can see that we have got access to it. So so the model ID is used as an endpoint in Lambda for accessing it. You can see it in the code section. So it will be used in the model ID section. Yeah, this is about AWS. Pretty straightforward. Let's look at a demo for local. So it's a local demo. So first thing is that I need to start my Akka server, so I'll be doing that. So my Akka server started at port 8080, and let's look at our endpoints. So these are our endpoints. We have health check endpoint, we have single query response, and we have the conversational query response. So I'll be using Postman for this. Let's check the health first. The Akka server is running. We get a sample response that LLM service is up and running. Let's try something new. Let's like add a random URL and see what happens. You see we're getting a 404. The resource is not found. Next we can have the single response query. The single response query is just one iteration from the AWS Bedrock. Ollama is not involved here. This is kind of a testing path that I implemented. So here we have the input and the output. The input is the same question: AI, how could it, if you have any superpowers, what would it be and why? And AI says that power of omniscience. Next thing is conversational query, and the input is same. We do provide maximum words and the input. Let's send a request. So request is sent, and the output is that the job is submitted successfully. Shortly the output will be available at a local address, right? This is a local address, source main resources. Let's see the output here. It's running for me. So how this works is that first we ask AWS Bedrock the question: AI, if you had any superpowers, what would it be? And whatever the reply that comes from AWS Bedrock, we use it for as an input to Ollama, saying that give me one follow-up question for whatever the response that Bedrock gave, and whatever question that Ollama generates, we pass it to Bedrock again. Bedrock replies, we create a follow-up question using Ollama, and the cycle goes on. So we use 2 iterations. It is complete, and the file is created at it should be available under the resource folder. sometimes it doesn't generate automatically. I mean, so just get it. Yeah, so the response is that I can go back here. Yes, it is created. Delete. So this is the one, the response that is generated right now. So you can see whatever the same question and response from Bedrock. Ollama replied again with a follow-up question. AWS Bedrock replied with answered the follow-up question. So cycle we can create more iterations by just changing the iteration variable here. So this is the demo for local, stopping the server. Next I'll be going through the demo for Docker. For the Docker, I do have the steps to execute in Docker. First thing is that we need to update the configuration file, and we need to set the environment as Docker, so that this environment variable is used to Docker output path and Docker host. So these are next is I need to install Docker, which is already installed. I need to set up the Ollama container. I have the steps here to be ran. I do have Ollama image, Ollama slash Ollama, and it has Llama 3.2 installed, and I do have a container which is active and the Ollama is running over there. So yeah, that's about setting up the Ollama container. Next we have to build our application. So let's build it right now. I'll do SPT assembly so that a new jar is created. So the jar is refreshed now. Next thing is that we need to build a Docker image. So Docker image, I need to give a name for the Docker image. I'll say record. So Docker image is created. Let's see if the Docker image is uploaded here. Yeah, we can see that. Next is that we need to start the Docker. So we do have two images here. One is Ollama image, one is Docker image, and we need to run both of these containers parallelly. And these two containers will communicate each other using the Docker network bridge. So that is why we are opening the ports for them. So I will start the Docker with the Docker run. So the 8080 port from local is mapped to 8080 port of Docker, and the Akka server and the Llama server will communicate using the Docker network. So we need to have a container name. I'll say the container as, I'll suffix it with a record. Even our image also as a record. The Ollama container is same. They are linked. So I'll start. So I got the acknowledgement that the container is started. Let's check if container is started. So I do have the record container started. Cool. So now we can make the same request and everything should work. So if server is working, random URL should not work. It's not working. Single query request. It's also working. Conversational API. So job is submitted and the output will be available at slash LLM. So this is a Docker path. Let's see the output in Docker container that what we are running on. Yeah. So the chat has been started between Ollama and AWS Bedrock. We're in iteration 0. The logs are loaded in batches, so you don't really see logs one after the other. It's not precise. Yeah, it's running the iteration 1. So this is the last iteration. Yeah, chat has been successfully completed. So we can see the response in the container itself. As I told earlier, that we should be able to find it in the LLM file path. So here is our output. The output is the same as what we saw before locally. So same question, same answer as well. It has to have the power of omniscience, and we ask if you follow up questions. Ollama asks these follow up questions, and AWS Bedrock replies with that to this question. It's cool. Cool. Yeah, this is about the Docker presentation. We saw a demo for both local and Docker. Thank you.